Okay, I wanted to review with you guys real quick the types of plate boundaries. And if you remember, there are three types of plate boundaries that we talked about: convergent plate boundary, divergent plate boundary, and transform plate boundary. And different things occur at different types of plate boundaries depending on kind of what plates are colliding or separating, or what the density of the plates are. So the first type of plate boundary that I want to talk to you guys about is convergent plate boundary. And as you can see over here, it says it's where two plates collide. And so what happens when the two plates collide sort of depends on what type of plates are colliding. Because remember that we talked about different plates have different densities. Ocean plates are denser than continental plates. And so it depends. Are we having two continental plates colliding? Are we having a continental and an oceanic plate colliding? And so the different plates that collide cause different things to happen. And so what I have sort of what we did with the lab to kind of remind you guys what happens. And so remember, we had two different types of pads, foam pads that represent the different types of plates. These thicker pads were representing continental plates because the continent is thicker than the oceanic plate, and they're also less dense than these thinner pads. Remember, the oceanic plate, because of all the water and all the pressure and stuff pushing down on top of it, tends to be more dense than continental plate. And so what happens when the different plates collides depends on the densities. I'm going to start with two of these continental plates, and when they collide, remember, because they have the same density, they don't, one of the plates doesn't sink underneath the other one. They both buckle up on top of each other, and then we get these huge, gigantic mountain ranges. Remember, we talked about India was like a continental plate colliding with like the Asian continental plate. And so what we see over there is these huge, tall Himalayan mountains. The tallest mountain in the world, Mount Everest, is over there. And so because they're both the same density, they both buckle up and create these large mountains. All right, when we have one oceanic plate colliding with one continental plate, what happens is very different. Since the ocean plate is denser than the continental plate, what happens, see, is the oceanic plate will sink underneath the continental plate. And so we get several things that happen here. We get a trench right here where the ocean plate is sinking back into the earth, but we'll also get a mountain range because it doesn't sink back into the earth smoothly. It will get caught on these continental plates, and it will kind of crumple up the continental plates. And so we get a trench, but we also get a mountain range on the continent. And then some of these mountains can actually be volcanoes because as this is sinking back into the earth, remember, it's very hot inside of the earth, and so the plate will start to melt. And these tend to be kind of very violent volcanoes because the ocean plate is saturated with water, and once water is heated, it expands, and so there's lots of trapped gases and water under these volcanoes, and they tend to be very explosive. So like Mount St. Helens would be an example of that. All right, divergent plate boundaries are where two plates separate. And remember, the reason that they're separating is because we have lava that is coming to the surface and pushing them apart. And so we don't get a trench. It would make sense that if they're separating, there should be like a giant trench down there. But that's not what happens, because the reason they're separating is the lava is coming up and pushing them apart. And so instead of a trench, we actually get a mountain range, an underwater mid-ocean ridge, a volcanic mountain range. And so these are actually the longest mountain range in the world is where these divergent plate boundaries are. All right, and then the last plate boundary is a transform plate boundary. And that is just where two plates slide past each other. And so what happens is we don't get land being destroyed or created. The plates are just sliding past each other. But we can get some very large earthquakes that occur because the plates aren't smooth. And so again, they don't slide easily past each other. They get hung up and they build up lots of energy. And when that energy is released, it creates these large earthquakes. The San Andreas Fault area would be an example of a transform plate boundary. We got part of California is sliding north, so like the southern part of California is sliding kind of north.